Today we're going to be talking about vocabulary involving the Pythagorean Theorem. So Pythagorean Theorem deals with right triangles. And a right triangle has three sides to it. The two sides that make the 90-degree angle are called the legs. This angle is 90 degrees, and it's also called a right angle. We know which ones are the legs because together they make the right angle. They are perpendicular. I'm going to write that too. Perpendicular, that means they form a 90-degree angle. The longest side of a right triangle is called the hypotenuse. It is opposite the right angle. It's on the other side of that right angle. So quick practice, we're going to label the hypotenuse with H on each side of the right triangles. Now, the right triangles don't have their right angles labeled, but the hypotenuse, there's an H, hypotenuse is the longest side. And since it's the longest side, I could just look for whichever side is my longest one. And then if I put my right angles, it's opposite of that. On right triangles, the right angles should be labeled. So how do you know which side of the triangle the hypotenuse was? It's the longest and opposite the right angle. So the Pythagorean theorem is a way to find a missing side length of a triangle, of a right triangle. So that's what its purpose is. Find the missing side of a right triangle. So here's our right triangle. We have two legs that make up the right angle, and then we have our hypotenuse. The Pythagorean theorem was named after Pythagoras, and he was a Greek philosopher. Hold on a second. He was a Greek philosopher and a mathematician. And he's the one that discovered a relationship between the side lengths of a right triangle. And the relationship, as was discovered in our warm-up, was that if we take the square of the legs and put them together, that's going to equal the square of the hypotenuse. This theorem only works for right triangles. Okay, we're going to use two colors to represent the different pieces, the different squares here. So I'm going to shade these 1, 2, 3, 4, 5, 6, 7, 8, 9. So with a side length of 3, it's going to have an area of 9. For the side length of 4, it's going to have an area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, if I put them together, what I'm going to do is take my 16 pieces right here and color in the bigger square, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I have some more left over, so I'm going to take that, my pink, which was what with my 3, and I'm going to shade those in my bigger square as well. There were 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And it matches up perfectly. So the theorem states a squared plus b squared equals c squared. A and b represent our legs. Leg 1, if I square my leg 1 plus I square my second leg, that's going to equal my hypotenuse squared. So the square of my legs together is going to equal my hypotenuse squared. A squared plus b squared equals c squared. So a and b equal the legs, and c is the hypotenuse, which is the longest side. Using this information from the relationship, we can solve for missing side lengths of our triangle, which we'll get into later.